In this chapter, we are going to look at the basics of Remix IDE and the structure of a simple smart contract. So let's start with Remix. It's easy to learn the basics of Solidity using the Remix IDE. It is a browser-based IDE where you can create and deploy your smart contracts. In the long run, though, we need to set up a local development environment, but this will do for now. It is good at the beginning because we don't really have to install anything and everything comes out of the box. And we can write Solidity code directly into our browsers. You can just go to remix.ethereum.org and follow along. Once you go there, you will see a page that looks just like this, and you will see a bunch of options. The one that we are going to focus on is Solidity. You can just click here and this page will open up, Solidity compiler. By default, you will see this file explorer, Solidity compiler, and deploy. So these three should come by default, and I have more than the three because I have added those plugins from here, but you don't really need it. For this class, all you need is these three, and they come by default. So the first thing, look at this file explorer. You click on this, file explorer opens up, and this is where you would typically write your smart contracts. This storage.sol comes as a sample smart contract by default, and the rest is counter, types, and struct. I have added these. You will not have those, but you don't really need it for this chapter. All you need is storage.sol, and I'll come back to this and show you the structure of a smart contract. But for now, let's move on. Another thing I want to point out about Remix IDE is this settings button. Click on it, and the settings, this is fun to play with. First thing that you will see is dark theme. So your remix.ide might look a little different than mine. That's because I have chosen the dark theme. Yours might look like this. There's other ones like mid-century as black, candy, which is kind of fun. There's cerulean, flatly, and so forth. You choose whatever you like. I will go back to dark one because that's what I like the most, and I will use this setting for the rest of the class. There are other things other than the theme. You can wrap. You can change the text wrap, or you can add a GitHub and you can code directly in GitHub and pull the codes directly from GitHub. All right, so let's look at other things. So we have this storage.sol, it's a smart contract. Now let's say we want to compile it. We learned in our older classes that you have to compile a Solidity program before you can run it. This is the program that already came with the Remix IDE. So now you want to compile it. So we will compile it. We just hit this and it gets compiled. So once this is compiled, this will show up. If you had multiple contracts in the same file, and the drop down would have actually showed you multiple options, and you would choose the one contract you want to compile and hit that and compile it. And then once you have compiled, you will get the ABI and the bytecode. Let me show you how it looks like. So this is a code. In the ABI, you should be able to see the store function and the retrieve function, and also the input of store function. And in this case, there is no input, just the output. All right, so look at the ABI, and here you go. So yep, here's the retrieve. There's no input. Here's the output. So it's a view function. There is this input for the store function. The store function has no output because it really doesn't return anything. Going back, the store function doesn't return anything. It has no output. Retrieve function, it has an output but doesn't take any parameters. So we see exactly that in the ABI. Now let's take a look at bytecode. This is the bytecode. It does say bytecode. It actually also includes the opcode and other things. The bytecode part of the bytecode is actually, this is the bytes that actually gets deployed in the Ethereum network. And this is the opcode. So now that you have actually compiled it successfully, means there was no errors thrown during the compilation time, you can actually deploy this. And for that, you'd hit this button, which is the deploy button. And you can choose the environment. Like you can use your MetaMask and choose mainnet through that, or another Web3 provider that you have running in your local machine. But for this class, we are going to stick with JavaScript VM that comes with the Remix IDE, and that's also the default. It's always choosing JavaScript VM. Just notice this account, and by default it comes with all these accounts with 100 fake Ether each that you can use to fake deploy in your fake JavaScript VM network. And the gas limit and the value, if you want to send a transaction with Ether, then this is what you would use. And also again, a drop down to select which contract you are actually going to deploy. We only have one contract, so there's only one here chosen by default. It's very similar to what you saw in the compile part. And then all you do is hit deploy. So you see the transaction go through right here, and it got deployed at this address. You just copy it, open the Sublime again, Yeah, you can see the address of this deployment. So this is the address of the smart contract where it got deployed. Now, if you hit this button, it opens up an interface to interact with the smart contract. We can actually retrieve the states, and we can actually even talk to the smart contract, call the store function, pass in a parameter here, and you can see it go through and changes the state and stuff. Yeah, so that's where that comes from. Blue button is actually a view function. What is a view function? View function is this retrieve function. It says view right here. So that's why it's blue. It is a function where you don't really change the state. Retrieve function is just retrieving the number, so you don't really change the state. That's why it's blue. The orange one is store, where it assigns whatever parameter you pass in here to the number. Here it's the state variable which is stored in the blockchain. So that when a button actually changes the state of the blockchain in Remix, it's orange. There is also a red button that you will come across later whenever you pass in a value here, which is actually saying, hey, I want to pass in 1 ether to this function, or give 1 ether to this contract. And a function that takes in ether is payable, and those will show up as red buttons here. But for now, retrieve and store is all you need, and maybe towards the middle or the end, you'll see this red button. But you should know that there is also a red button payable type. That means there's a payable type action. So return it to 0, and let's change something in this contract. Instead of store, we call it store number. We change this, so we will deploy this again. See that deployment goes through. The first thing to do before deployment is compiling. So compile it, and we can check the API to see that it actually compiled the new thing. Delete it, paste it. And you can see the function name has changed to store number. So it compiled successfully. Good. So now we have compiled it. We can actually deploy it just like before. This was our previous deployment. We deploy it, and we'll see a new instance of our deployment with a new address. If you copy this, and you can actually see it from here, we don't really have to copy it. It was 0xT913913B, and this one is, starts with 0xF8E, ends with BB. Pretty different address than the one deployment before. And yeah, so this is store number. Earlier deployment was store. So every time you deploy it, you get a new instance, and new instance is actually a new address in the blockchain, and you can interact with it just like before. Okay, so this is pretty much the basic of Remix IDE. There's not much to it. All the transactions here, you can actually click on this and look at the transaction from which address you sent to the contract address and so forth. Oh yeah, so another thing that I should show you is earlier you saw everything was 100, but now one of those accounts, which is used by default, has dropped to 99.99, a very small amount, but dropped nonetheless. That's because every time you do a transaction, some ether is used. So every time you hit this orange button, which is a transaction because it changes the state of the blockchain, some ether would be used, and yeah, this amount drops. You also send a transaction because while deploying a smart contract, because you're actually adding to the blockchain, it's also considered a transaction. So you also need some kind of ether to deploy. You don't have to worry about that while testing in Remix. We can use this to test whatever. These are not real ether, so don't get excited. You are not rich yet just because you opened up Remix.ide. You cannot buy Lamborghini with it, but that's that. Okay, so now let's look at the storage.sol and go over the basic structure of a smart contract. So the first line, the very first line, you see the pragma directive. It says pragma solidity greater than equal to 0.422 but less than 0.7.0. So what that really means is this file would be compiled using the Solidity version that's greater than 0.4.22 but less than 0.7.0. Every file, every source file should be annotated with version pragma that says how to compile this file. So you can have big project with multiple files, and each file will have pragma directive. The second thing is this number. Whenever you see a variable which is like initiated inside the contract but outside any of the functions, it's actually what we call a state variable. This is a state variable. So a state variable is something that is stored in the state of blockchain, and we are going to go over these details later. But just remember, this is a state variable, this number, and then we have this setter function. This function is called a setter function because it takes in a parameter num and sets it to this state variable. And then we also have this getter function, which is retrieve, which takes in this number and returns. It just returns whatever the value of this number is at that point. So this is a very simple contract. All it had was a state variable with a setter and a getter function and a pragma directive, which you have to have everywhere. All right, so that's it for this little section. I hope you learned about the remix and basic structure of a contract.